Okay, so the purpose of having 4 of the engineering abroad students from the total 10 come to our class today to present is twofold. One, to show you how a true engineering project has been done using the engineering design process, and then also exposing you to what the engineering abroad students do. In the middle of April, we will have a presentation. They'll each be presenting for 5 minutes each in a different way on how the abroad program impacted to them, and I'll let you know. I think I've already advertised that it is going to be a Zoom call, but those of you who are engineering majors and plan on being at Cabrillo next year, you definitely can apply. So the first step is that in the middle of April, there'll be a presentation by the current abroad students, and then I will post the application. I haven't posted that yet. But Engineering 5 is getting kind of a sneak preview on what they actually did, and they're working through the engineering design process. Okay, you guys, go for it.
Alrighty. So, hi, my name's Aaliyah Wolkin. I'm a mechanical engineering major, and I'm partially in your class with AutoCAD. And then...
Hi, my name is Maria, Maria Ridgway. I'm a civil engineering major, and I also was part of the engineering abroad program in January, and I'm in class with you guys.
Hi, my name is Yuriti Barranco, and I was one of the fortunate 10 that went on the engineering abroad program, and I'm also part of your class, and I'm a mechanical engineering major.
Hey, how's everyone doing? My name is Omar Cabrera. I am kind of like agricultural and mechanical engineer, so that's kind of like fun to kind of see everything. And yeah, I had the great opportunity to go on the abroad program, and I was in engineering 25 last fall, so this past semester, and yeah.
So let me just interrupt. So both Omar and Aaliyah took this part of the engineering 25 class already, so they both worked on a group design project, and they actually worked on the project together.
Yeah.
In 25. Okay.
All right, so bear with us here. We're going to be doing a lot of sharing screens. Okay, let's see. I think this is the correct one. All right. Okay. So we're going to be going through the design process of our abroad trip, starting with stage 1, problem statement. The problem statement is the trout farm was polluting the river. Stage 2, problem analysis. So the trout farm that we dealt with was owned by a man named Engr. There's 2 small ponds on a hillside. One was generally the size of like a swimming pool, maybe a little bit larger. The other one about half, as you can see right here. These are the 2 of them, and that's Engr. They held about 1,000 fish total. The pond was elevated above the river about 20 feet along like rocky terrain hillside. And I'd say that the slope distance from the edge of the pond to the river was about 75 feet. We knew that fish poop was what we had to target. The poop was polluting the river whenever the pond would get cleaned, because generally when they just left it alone, it would settle at the bottom, but during cleaning time, it would get agitated and come out of the outflow and go into the river. So we knew we had to deal with that. So some things that we did is we timed how long it would take to fill a 5-gallon bucket. We also did a settling study, as you can see right here, how long it would take to settle to the bottom. Also, a quick note back here, right here where this person's standing is about where the river or the pond ends, and then this is the slope downwards, part of it at least. And then we also did a rate of flow measurement from the outflow pipe to see how fast it was coming out of the pipe. And also we found out that the size of the pipe coming out of the pond was 4-inch in diameter, and this affected how we chose our piping for the system that we wanted to build. And then I'm gonna hand it over to Maria to go over stage 3.
Okay, cool. 1 second. Let me just figure out.
Maria, just hang on a second.
Yeah.
So does everyone in Engineering 25 see how, the problem statement was this short problem, but stage 2 talked a lot about what the details of the problem were, what the pond was like, what's the size, what kind of fish was it, how many fish are there? It's the poop that's polluting. Where is the outflow? When does the poop pollute it? It's when it gets agitated. What's the land look like? What's the distance from where the pond is to where the river is? What's the elevation change? All that stuff was needed in order to understand the problem better. Thanks, Aaliyah.
All right, so I'm gonna share, hold on just a second. All right, so I'm gonna be talking about stage 3 of the engineering design process, which is the specs and constraints of our project. So these are kind of like the speculation and constraints that we put on the project, or that were put on our project, that aren't like the physical kind of like, yeah, that aren't part of the problem analysis. They're not like the facts of the problem. They're more just like the constraints around like what kind of solution we can build. So included in that is like the schedule, the budget, materials, environmental impact, aesthetics, and labor. So for our project, for example, we had a schedule. All of the materials that were sent to the job site before we arrived had a budget of $1,200, for example. We also had a schedule. We knew that we only had 7 days to complete the project. And as far as labor went, we knew that we would only have 7 people working on the project, as 3 other people from Engineering Abroad were working on a separate project somewhere else. So with those in mind, we needed to come up with a solution. We wanted the solution to be aesthetically pleasing as well. So we wanted it to incorporate, we wanted it to be, like if we chose plants, we wanted them to be native plants. So we wanted it to, like the solution to be aesthetically pleasing. We also wanted our solution to be sustainable and to be maintainable. So we wanted a solution that was simple enough that it could be repaired easily, and we wanted a solution that incorporated all like local parts that could be bought in Costa Rica, so that they didn't have to depend on getting the parts from somewhere else. The picture that I'm showing you guys is a picture of us in the hardware store in Costa Rica. Probably one of the biggest constraints on our project was that we had to come up with a really precise list of materials before we made it out to the job site, because the closest hardware store was 3 hours away. So that was a pretty big constraint on our project. Another example of a constraint was we had to think about the materials as far as transportation as well as materials, sorry. So this is a funny picture of us on our daily journey to the job site. We always rode in the back of the truck. Besides thinking about transportation, we had to think about the tools that we needed, what tools we were going to bring with us, what tools they had down there for us to use. So those were further constraints. But yeah, basically, those were the constraints and speculations of our project. Now I'm going to hand it over to Eurydice, unless you guys can think of anything else.
I think you named them all. But let me try to share my screen now.
Okay, I got to stop sharing mine, I think.
Oh, okay. Okay. All right. So I had the brainstorming section, which is stage 4. So here, when you're brainstorming, like Joanne said, you're just throwing out a bunch of ideas and no one is judging you. You're just jotting a bunch of things. And when you're brainstorming, you're also thinking about the design specs. So like Maria mentioned, so these are some of the things that we brainstormed. Let me just, right here. So here, this is the 3 projects that we did, the trout farm, the solar panels, and the shredder. We're going to only talk about the trout farm because that's what me, Maria, Aaliyah, and Omar worked on. So there was 3 things that we really focused on when we were brainstorming. Was the type of tank, what type of filters, and then what type of bioswales. Here we jotted a bunch of things of different types of tanks, filters, and bioswales. And right here, this is a picture of this is an example of what we use for the filter over at Costa Rica. This is the burlap sack. So right here, the tanks we jotted down what kind of tank. So above ground tank, polyethylene, in ground, wood, metal, height. So there's a bunch of things that we were considering. Or would it be gravity fed, like what things? And then for the filters, what type of filters? So we just named a bunch of different like materials. Burlap sack, which is this one, sponge, nylon filter, polyester filters. And also when you choose a filter, they have different patterns. So that's something to consider too. And then for the bioswales, there's these 3 that we mentioned, which is grass channels, wet swells, and dry swells. This one right here was the cheapest out of all of them. And I believe that we went with the dry swells, right guys?
I think so. Dry or wet? Because in the end, they have the plants.
The grass is the one that I think you substitute. Oh no, we went with the dry. The dry swell is the one that you substitute whatever is in the ground for like grab. Yeah, the things that we brainstorm. We have a lot more though. Just some of the, yeah. Omar, let me pass it over to you. Let me unshare this. Oh, there you go.
All right. So here's kind of like the solution that we came up with for all of the brainstorming ideas that we had, and kind of everything that we had. We came up with coming up the filter, with the barrel filter, which is this is a prototype that we worked on back here in California, and we liked the principle of it, so we kept it. But just like all design processes, right? You kind of like start off with something that you think is gonna work, and then however it is that it works out, you take whatever's and you keep on building off of that, and you work on whatever's not working. And so this is kind of like the very beginning process of it, to like the overall done process, which is this is like the workings of everything. And this is where you follow the blue arrows, that's the flow of the water, and kind of like the way that it works through this whole filter and settling tank. And the settling tank is like kind of brought in through a 1-inch PVC, which was choked down from 4 inches to build up pressure. And then that way it is all like gravity fed, and you don't have to like have a pump. So there's not like a lot of mechanical errors that can go wrong, which goes into the whole reliability and easy to work with. And from here, this is like the inflow of the water, which is this tank, which is this pipe right here. And then this giant 8-inch PVC is a sleeve that goes on the top of it, and it slows, or it like calms down the turbulence, so that way any fish poop that is kind of like or is in the water settles down to the bottom and ends up all right here. And then the water ends up going through here, which is a lot cleaner, and then goes into the filtering barrel, which is this one. And that's where the burlap sack with hay is, so that way all the finer material would get caught in to that burlap sack. And then this is the both of them kind of like in parallel, so that way you guys can kind of put this, I guess like kind of like the blueprints of it together with the actual reality of what happened. And that was the workings of the kind of like to clean out the water a little bit with all the settlement that you can see. And then from there, it would go into the bioswell, which is this is the overall end product that all of this water that seemed clean would end up going into the bioswell, and then just through nature and biology, it would kind of clean out all of the whatever kind of like germs were still in the water, the whatever bacteria was still in the water, and this would kind of clean it all out. And as you can see, we had big boulders in the very beginning of on the bottom of the base, so that way erosion would like not happen. And then we would throw on finer gravel, and then we put the plants at the end, so that way it was both it would help with water retention, so that way all the water wouldn't have to be all like just sustained by the bioswell, but also the plants could suck up some of the water, and also for aesthetics. So kind of worked out for two different reasons. And that was kind of the overall workings of the bioswell and the settling tank and the filtering of the water before it all kind of goes into the river again. Much cleaner. But yeah, that was kind of the overall workings of the system, unless my team kind of thinks that needs some, maybe.
I think it's pretty good. Just,
Good.
you know that the water right here where Omar shows, like, or do you want me to share my screen, Omar?
Yeah. Or someone
Yeah.
should share it.
Yeah, you can share it.
Okay. Well,
Yeah, I saw.
Let me see. How do I? Just so you know that the water, it's going to exit out through here. There's like a little retaining wall right here along the bioswale, and it has tubes where this water will, if it, what's it called?
If it overflows.
Yeah, if it overflows, it's going to go through those tubes. And then so you know where the water is coming from, the lake is actually up here. You just can't see it from this profile. Just so, yeah.
And this tube, oh, I can't show it with my computer, but.
Do you want to share? Sorry, Maria.
Yeah, I could try sharing. Where is it? Sorry. How do I go to the next one?
There's little arrows at the bottom.
Okay. So this tube right here, the water originally came out of a tube over here on this hillside and flowed down the hillside directly to the river. Right now, the view that we have, the river is behind us, basically. But this tube transports the water over to the system. And another aspect of our system is that we wanted to be able to like manipulate its function. So we wanted to be able to put in as much or as little water as we wanted to in the tanks, and also be able to put the water in the bioswale just on a regular day-to-day basis, because the tanks were mostly targeted, like we used the tanks mostly during the cleaning. So we put in another valve over here so that the water could also just directly flow into to the bioswale. And the reason that we use like the top, we use lava rocks, and lava rocks are important in this type of bioswale because they are very porous. So basically it increases the surface area for bacteria to grow on, like the necessary bacteria that breaks down the nitrogen from the fish poop into something that the plants can eat. And the plants are important also for that reason, because not only do they like help keep the bioswale like aesthetically nice and prevent erosion, they also do have a big part in cleaning the water and using up the nitrogen that's produced from the fish poop. And then I think that was just the only things I wanted to add to that. So do you guys have any questions? I can kind of leave, we can leave the slide up and you guys can be like, can you go back to that? Or we were confused about this or whatever. If you guys have any questions about the design process or about the solution, if anything wasn't very clear, let us know.
Can you hear me?
Yeah.
Cool. I have a question about like your job site up there. Did you have any like overall developed site plan of like where things were going to go and like measurements for pipes and stuff? Did you have to do that on site after buying things?
Yeah, we had to do that on site.
Oh.
I mean, yeah, because we really didn't know. I mean, all of this that you see right here, we dug all of this by hand. This was all dug out by hand. Like,
Damn.
and this is like already full of boulders, but imagine how deep it was even without the boulders. And the soil, if these boulders are all just from the surroundings, imagine how the soil was. Like, it was so rocky.
Wow.
It was crazy rocky. Yeah. And one of the things we had to do was survey to make sure that the lowest part of the highest part of the tanks was lower than the lowest part of the pond, so that the system would be able to be gravity fed.
Mm-hmm.
Did you guys run into any flow problems?
Any flow problems?
Yeah.
I think as some of the follow-up, I think we heard that maybe the flow into the tanks was kind of slow for the needs of like the cleaning process, like how fast they needed to get the water to go out and get fresh water. But while we were there, we didn't have any problems. We just had to make sure to regulate the flow so that the tanks, not more water was going in than was coming out.
Sweet.
I have a question.
Oh, go ahead.
Yeah. Back to like that, I guess you could say like a blueprint of like the drawing of the pipe.
Yeah.
Did you guys like, well, obviously you built it, but did you guys get any help from like people that you guys were working with, or was it just you, like the students only that came up with that?
Go ahead, Omar.
Yeah. No, yeah, it was like a shared group's idea, I think, and it was kind of like I think everyone had an input on what the end result was going to be, and we just kind of I think like, yeah, we just kind of ended up doing a lot of the design processes like over here, so that way when we got over there, it would just be like almost like you're just running it.
Start right away.
Yeah.
But we did get help from our TA. I mean, like who? Yeah.
Sorry.
Okay.
Well, yeah. Before designing any of it, like we did have to do research on what a bioswale is and how does like filtration systems work. Like we didn't automatically just think of this like blueprint, like just like that. If that's what you're asking. No, that's not. Yeah. We did not do that. We had to research.
That's like my next question. How many like methods did you guys come up with before you decided like, yes, this is it? Like this is what we're gonna do. Like, did it take you guys a while? Or?
I think what we struggled the most with was trying to decide what piece of the system we were going to target. Like if we were going to target just the cleaning time, or if we were going to like try and target how they cleaned the system, like if we were going to change how they did their maintenance, or if we were going to do something aside from that. And which we ended up doing. We ended up doing something different, although it may still change how they do their maintenance.
Yeah, and I think it also kind of like just depends, because like, I mean, if you really think about it, like this project is like 3 different systems. It's like settling tank, and it's a filter like medium, and it's a like a bioswale. So it's like kind of like, yeah, it was like everything was always like kind of like changing, because we were dealing with like essentially like 3 different projects that were like within one. three different aspects of the project.
Yeah, and trying to get them to like come together.
Yeah.
But I think we always had the idea of like, okay, I mean, once we got the tank idea, it seemed like, given the constraints and given that we didn't know exactly where we were going to be and like we'd never been to the job site and stuff like that, it seemed like the most feasible and most adaptable solution that we could kind of like work with there and change and stuff like that.
For sure. Yeah, yes, because it looks really cool. Like, I'm really, really impressed. So good job, guys.
Thank you.
Thank you.
I have a question.
Yes, Angel.
Who drew that picture of the piping?
Brandon.
Brandon.
Does he know who
Very
Brandon
cool.
is?
Yes, I've met him before.
Yeah, he's our
Okay.
TA.
Yeah.
Hey, I also had a question. Were you guys assigned this job, or did you guys kind of just pick it?
They gave us a.
Well, we said what ability we had to do, and so they sent us a list of like maybe 4 things that we could do, and we focused on the main one, which was this project, and then we left 2 more projects open to possibly do if we had time, and so we ended up also doing those 2 projects with separate people in the same like a broad group.
Yeah, so basically it was like a collaboration between us and the organizations down there, based on like what we could do and what they needed done.
The organizations aren't engineers, they're just like volunteer groups that do like cementing roads and stuff, and we just partner with them. And so us plus Brandon and a little bit of help from Joanne and Carl all together decided what we could do and work on that would be realistic.
Can I ask a quick question?
Of course.
So what impacts was the fish poop having on the environment?
It was starting to raise like the nitrogen levels in the river so that they would see like increased algae blooms.
Oh, okay.
Yeah.
And
just like white foam at the beginning. Yeah, downstream from the fish farm. And there's one of the goals of the project, or one of the ideas, is that this is also like a scalable solution. So like if this works, then it could be something that's implemented at other fish farms in the region, because this is just like a really small, like 1 family farm, but there's several of those. And so like if this proves to be like a good solution, then it'll be able to like replicate it at other farms.
Okay, cool.
Yeah.
Any other questions?
I had a question. While we're still on the topic of fish poop, right on the slide, where like you guys were measuring like the settling rate. Was that actual like fish poop that you're testing? Did you have to scoop that out?
Yeah.
You guys had to scoop it out yourselves? Like.
Yeah.
No, it's water from the trout farm.
Yeah.
Okay.
Did they send that to you back to the States?
No.
Or did you have to do that down there?
Yeah, we did that when we got there, but in terms of like a perfect design process, we would have had them do it prior.
Mm-hmm.
But.
So the water, sorry, I have a question. So to that picture with the sediment and the fish poop, did you do that same process to the water that you guys filtered to see?
Partially.
Like, partially?
Yeah, because I'm 2 tanks do 2 different things. Right, Maria? Yeah. Yeah. So like a gravity, and the other one just uses a filter to catch the poop.
I mean, we when we ran this system, we didn't run it during the cleaning time of the fish pond, because like we really only got it done on the last day, so we didn't actually get to watch it do a full cleaning process. But while we were running it just with regular water, or with just like the everyday water from the fish pond, we did start to see stuff settle at the bottom of the big tanks. So that was pretty cool to see. but we didn't get to do like an agitated settling study with the filtered water like we did with this picture, with the one in this picture.
Watch if you go to like the slides at the end, I think there's like one where you can actually see like some of the fish poop starting to settle there at the bottom. Right there. On the second picture in between the
with the burlap sack?
Yeah. That no. The one where you were at. The white one. Yeah.
Oh.
All of that settling is fish poop and like sediment that was in the water, like even just when the water looks like clean. So all of that was just in that water. So can you imagine like when it's like really agitated, it's actually going to be like a lot more filled in. Just the very beginning process.
Yeah, this is the bottom of the tank, and that brown stuff is like the fish poop.
The poopies.
You've got a question from chat.
Yeah, someone in the chat was asking how the fish poop's disposed of. So our thing was that during their cleaning, like what they do is they do clean the ponds, and what they do is they scoop up like the fish poop and the sediment and put them in bags. But during that process, some of it was being lost in like out of the outflow. So that process is still happening, but what we targeted is like the stuff that got missed and was going straight into the river. So I don't know if you guys, the other broad people know, but
well, I think so what they do with the fish poop is it's a great fertilizer. So once they scoop it out, they dry out the sacks that they scoop it out in. Basically, they use those same burlap sacks that you saw in the tank, and they put it in these sacks, and then they dry it out, and then they spread it on their plants as fertilizer, and it's really good fertilizer. But over here, there's another outflow for these tanks that when they fill up with fish poop, they can open the, let me go back to this shows right here that they can open these valves right here. So like, let's say the fish poop settles in this tank and it settles in this tank. They can open the valves and then have it just flow right into a bag. And then the bag can dry out, or they can leave the bag to dry out and then use it as fertilizer. It's actually really valuable stuff. And that's why that was one of, I guess, the constraints is that we wanted to make sure that we could save the poop as much as we could.
Could you guys hear me?
Yeah.
Okay. What I'd like to do now is stop the abroad discussion, because the main point was for you to understand how they went through the engineering design process, and that's the goal for today's class. They're going to give that presentation on April 17th, which is a Friday from 9 to 11. And then you could watch their presentation, and then you could ask more questions about the specifics of the design. Okay. One thing I would like them to comment though on, and this was kind of related to Enrique's question, I think that many of you might look at this and say, oh my God, this is not something I could do. And I want to ask the four of you, have you ever did any kind of work like this before?
I've never done that.
Were you a little
not that in depth?
Okay, were you a little stressed about going on the abroad program knowing that you have not done this stuff before?
Yes.
A bit, yeah.
I was extremely stressed.
Okay.
Oh, yeah.
And in the end, do you feel like anybody could do this work?
Oh, yeah, definitely.
Okay.
The only engineering class experience I had was 25 and engineering 5. That was all I had.
So I'm extrapolating what your question was, Enrique, but I think that that's a big concern about students when they decide whether to apply or not. They feel like, oh, I don't have any experience. I'm not going to be good at it. I'm not going to be able to do it, but you totally can. You learn, you do the research, and you're a team, and everybody brings to the team something different. So, and then you have guidance from the teacher and then the TA, which is Brandon. So I'd like to just stop the discussion on abroad and just say thanks and give them a round of applause for thinking to come to class. And
this is better if you have a camera.
Thanks, guys.
So Aaliyah, you could sign out now, and Omar, you could sign out now. Thank you.
All right.
Bye.
See you later. Bye.
Bye.
Great job. Okay. So now do you feel like you have a clearer, now that you have one example, you have a clearer idea of how you go through the design process there? The first stage was that the poop was contaminating the river. It's a one short sentence, right? The next thing was the problem analysis. They needed to really research what is there right now. And then stage 3 was figuring out what the limitations were of the solution, which is the amount of people they had, the materials, the equipment, the time, the money. And then they went to brainstorming, and they did a hell of a lot of brainstorming. Euritzy just wanted to cut it down to okay, what are the 3 things I want to talk about now that we brainstorm, which was the type of tank, the filtering material, and what was the third one?
The bioswale.
The type of bioswale. But basically, they brainstormed a lot of other things, the types of pipes they used, what the size of the pipes were, et cetera. And then they came up with a solution, and you saw the solution. And now the solution is being tested. And during this next year, we're going to hear about how, well this solution has worked. And Maria mentioned that it could be scaled up for other trout farms, because there are a lot of these small mom and pop trout farms there, and if anything needs to be, after the testing, if anything needs to be tweaked, they could redesign it and make some changes to the one they have, or just make changes to the new designs. But that's the engineering design process. So what I hope now is maybe we could just go over, I'm gonna make something up, and I did introduce this in Engineering 5 because I think everybody could kind of picture it in their mind. It's a lot less complicated. So what I'm going to do now is I'm going to share my screen, and I'm